Hello everyone, my name is Wang, and I'm a PhD student at the Ohio State University. And today I would like to talk about how to detect 3D model clones in mobile games. And this is a joint work with my colleague, Dr. Chaoshun and my advisor, Professor Zhiqiang. All right, today I believe many of you have heard or even played the 3D games in the Metaverse. And in 2021, Facebook just renamed their company name to Meta, meaning they are shifting to Metaverse. And recently, they are acquiring some startups to boost their virtual reality ambitions. In 2022, Lego and Epic Games also seeks for partnership aimed for a kid-friendly Metaverse. And most recently, Apple just announced their most advanced VR headset, naming Apple Vision Pro, and it's ridiculously expensive. And yeah, so recently, I believe many of you have heard that there's some other industries is shifting to Metaverse, but more and more companies are investing in 3D games and Metaverse. But why? You see, there's a very important component of a 3D game, that is the scene of the game. And modern games are heavily rely on their scenes to provide more immersive gaming experiences, just like this example. But there's also another very important thing is 3D models. And as you can see in this scene, there are tables, there are little figure, there are chairs, there are lights, and don't forget the scene itself, and so on. All of them are 3D models. But you might think, all right, it's just so easy. You can, put all the 3D models in one game. That's it, right? But the thing is, it is very hard and costly to create 3D models themselves, just like the first meme. So, the crafting this 3D model is kind of some art. And, art will relate it to some professional works, just like the second one. They're gonna be very, very costly to create them. So if you're gonna put some free download badge on your models, and it's gonna be very, very more people to download it. And if you don't believe that, let's look at this 3D model. It's a human body model, and it contains over 900,000 of vertices and nearly 2 million of triangles. And this model costs over $3,000. So since the model is expensive and hard to create, then it should have been protected very well, right? So let me show this model first. It's a Sonic, which is a representative of Sega. But why I'm showing this? Because this model is I personally extracted from their games and rendered on my personal computer, and I'll show it to you here. Yeah. So this is not true. There's multiple reasons that 3D models are currently not being protected very properly. And firstly, the 3D model has to be distributed with games. And second is you have to render on your client. And lastly, for the attackers or thieves, they can extract their models very easily. And if you are typing some keywords like model getting stolen on the 3D model trading website, you can find there are so many authors that complain that their models are getting stolen. And then we must detect such stealing, right? But how? How to detect model stealing? Shall we detect models that look exactly the same? Unfortunately, this is not going to happen because the models can be very easily to be squashed, stretched, or rotated, and the raw file content will changed. And obviously, the file hash will also be different. And now the question is, how can we design a robust and efficient 3D model index scheme? Now, let's summarize our challenges systematically. So we have 3 challenges. First is, how can we design a robust algorithm to handle the noise in static 3D models? And second one is how to handle such noise in dynamic ones. And lastly is, since we're going to do the large-scale study, how can we do efficient algorithms? And here's our solutions. So for the first, we use a model representing technique by relative values. And for the animated 3D models, we use the animation interpolation. And lastly, we use an index-based 3D model database to conduct large-scale study. All right. Before we head into the technical details, let's look at how does a 3D model look like. So first, you need to name your model, right? So we use a G command to name a model. So in this case, it's going to be G USENIX. Then we use 3D coordinates with the V command to define like the vertices of the model. And after that, we can use the F command, which is face, to define those faces between each vertices. So as you can see, the vertices and faces is actually connected and they are related. So now we can introduce our static model, 3D model indexing algorithms. So for the raw file, we first sort the vertices, and then we map the vertices with the faces. Now, when we have the faces, the related faces, we can do the sort again within the rows of faces, and finally we do the crypto hash to obtain the final index. And for the animated 3D model interpolation, we just use the values of each dimension to interpolate a function. And by comparing those functions, we can compare the similarity of different models, just like this. And now we can dive into more real data points. So for data sets, we have downloaded our games from Google Play via using the gplay CLI, and we have finally obtained over 176 Unity-based games, which took over 5 terabytes of storage. And we then analyzed the games, and we found there are nearly 90,000 of games that contain 3D models, and we finally found over 22 million static 3D models and nearly 8 million animated 3D models. All right, now we can identify the cloned static cloned models by applying our algorithms, and we found there are over 5 million distinct static 3D models, and over 1 million 3D models are being found in different games, which means there are more than 80% distinct models only exist in one game. And for dynamic ones, we found that there are over 1 million distinct dynamic 3D models, and there are more than 1.5 million, which is 88% animated 3D model exist only in one game, and most of them exist in 1 or 2 games, which means we can conclude that static 3D model clone is more common than dynamic model clone. Now, we can look at some details. It's about the 3D model distribution across games. And we can find that popular games tend to have more models, but the model complexity is actually decreasing. And if you looking at the clone models, we can see that popular games tend to contain more clone models. All right, one more thing. We need to discuss the FP and FN of our tool. So we define that if some models are dissimilar, but we identified as similar, then it's going to be the FP. So we randomly selected 1,000 static models and 1,000 dynamic models, and we manually reviewing them, but we didn't find any models that is dissimilar, but we identified similar. So the FP is going to be 0. And another thing is false negative, which means that the models that appear identical, but they have different hashes. So this is actually a little bit harder to gather the false negative. So we gathered 50 common object words like book, like dog, and we randomly choose 30 models in each group. So which means we have 1,500 models in total, and we then manually review them, but we also didn't find any false positive, which means we didn't find any models appear identical but have different hashes. So during the manual reviewing, we also found some interesting cases, like the game clone. So for the game clone, there are some attackers may just directly repackage some existing games, and the original game and the repackaged one would have a very high overlapping rate. regarding the models. And for the ideal clone, that some attacker may just replicate the idea by creating a similar game. And this replication could possibly just borrow some models from the original one. And lastly is just model clone. Some attacker may just be interested in some specific models, and they just steal the specific model and use it in their games, which belonging to a different category. So let's look at some real examples. So for this one is Join Clash 3D. As you can see in the right side, the another game, they have just the exact same model, and they just change the textures, which has just have like 5K installs comparing to the original one, which have over 100 million installs. And the next one you guys probably more familiar with, it's Subway Surfers. And as you can see in the right side, they have just 100 installs, but the Subway Surfers is very, very famous. They have over 1 billion installs. So now we can conclude our work. So we are the first. We are the first to propose the open source robust tool, which is designed to identify 3D model clones within the mobile gaming sector. And we have evaluated our tool with over 176,000 mobile games. And we have some empirical results, and we also identified over 5,000 mobile games that are likely to have unauthorized clones. All right, we have released our code on the GitHub. Please feel free to use it. And if you have encountered any issues, please feel free to drop us some feedback. And that's all for today. Any questions?